So the first thing I would like to go back to and ask you if you had any questions on, quiet please. Tell me whether you had any questions on graphing polynomials. Degree 3, degree 4, degree 5, degree 6. Any questions on polynomials? I'm sorry? Yes, of course. Please choose any particular degree. Odd degree, even degree? Okay, quiet. Thank you. So we are looking at the following. I'm sorry? Perfect. So we have x to the fifth plus 2x cubed plus x squared. Okay, this is a polynomial degree. Degree. Very good. How many solutions will you find? How many x-intercepts? 5 x-intercepts. Very good. What is the maximum possible number of turns? Yes, max 4 turns. Does it have to turn 4 times? No, but it cannot turn. It cannot turn more. Very good, awesome. Can anyone give us the domain of this function? Right, it's definitely a polynomial function. Polynomial functions, I call them friendly. We don't have to worry about their domain, in other words. Very good. So let's find the x-intercept. We set very good. We always set y equal to 0. Awesome. So I see that I can factor out x squared. And let me see for a second. I may have to make some adjustments here. So when I factor out x squared, I'm going to put 4 here, and I'm going to put 3 here. So I had to make a little adjustment there.
Otherwise, would have to be an imaginary solution.
No, not necessarily. I just wanted to discuss some multiplicities. Okay. And if I factor x squared, I get x cubed, and I have to solve the equation with a graphing calculator.
With that change, wouldn't you then factor out x cubed instead of x?
Yes, I will factor out x cubed. So then I have x squared plus 2x plus 1 equals 0. And we know how to factor this.
X plus 1 is minus 2.
It cannot be. It cannot be. Very good. X plus 1 squared. So you will give me 5 solutions. We discussed that from the very beginning. Degree 5 solutions. So then please tell me what the solutions are.
X is equal to 0.
Say it again.
X is equal to 0.
How many?
3 times.
Very good. Indeed, 3 times x equal to 0 and?
Minus 1 2 times.
Very good. So x equals -1 twice. What is the multiplicity of 0 then? One more time.
3.
What does that mean? What does the function do there? Does it cross or turn?
Turn.
For the odd multiplicity, it will never turn. Remember x squared. Correct. So this must be a cross, but slow. What about x equals -1?
Turn.
Yes. Multiplicity 2, even multiplicity, always a turn. Remember x squared has multiplicity 2. That's why it turns at 0. Perfect. So I put those in the table. So -1 and 0. I get 0 and 0. And at 0, I write cross. Slow. And at -1, I write turn. And it's a regular turn. Now we have to establish the end behavior. Since it's degree 5, does it follow the first degree or the second degree function? It's a silly question. If it's degree 5, it cannot follow x squared. Right. So is it with a positive leading coefficient or negative leading coefficient?
Positive.
Right, so the end behavior is very clearly from negative infinity to infinity. Final step, symmetry. Please watch all the videos several times because just one problem or even two is not going to be enough. Okay, symmetry. I have to find f of negative x, which will be negative x to the fifth plus 2x to the fourth minus x cubed. Do you think that this function with a turn at -1 and a cross at 0 can be symmetric?
No.
No, of course not. So this does not equal negative f of x, and it does not equal f of x. It's not symmetric. The function is not symmetric. That's all I need. I'm done. Let's graph it. From left to right, I plot -1, 0, and I plot 0, 0, and now I follow my table. Careful. From negative infinity to -1, 0, turning. It has to turn again because it will cross slow at 0, 0, but slow means like this, not like this. Slow, and it's going to positive infinity. So this is the function we picked. F of x equals x to the fifth plus 2x to the fourth plus x cubed. What we don't know? Yes, please.
So how this line will turn downward? How we will know?
It has to. It's coming from negative infinity. It turns at -1, 0. It has to turn again to cross at 0. If it doesn't turn, it will never cross at 0. You understand my point? It's coming from negative infinity. It turns at -1, 0. If it doesn't turn again, it will never cross at 0, 0.
No, why is it turning downward?
But the turn means a turn.
Like it can go upward.
If it's coming from above and it turns, it has to go back up. If it's coming from below and it turns, where does it go? It has to go back down. So you're going north on I-5, and if you turn, what do? You go south. It's coming from below. It turns at -1, 0. It turns. It has to come back down. That's what a turn means.
Okay, got it.
Yes? Better? So let's take a look. In y equals, clear if you have anything else in there. X to the fifth plus 2x to the fourth, right? Plus x cubed. Good. So I know the action happens around 0, so I'm going to adjust the viewing window. -4 to 4 is fine. And -2 to 2. Because I'm assuming that the minimum is very, very minimum. Very minimal. You can't even see it. It's so small. So do not ever copy something like this on a paper. Because I can't give any credit for it. We know it's wrong. We know that that's not possible, right? This is not the function. We know that. Please don't. Okay? So let's go back. Let's say -0.5, 2.5. Let's see what happens now. Make sure you turn. So it's turning at -1, 0. It comes to whatever minimum, tiny, tiny, and then it crosses very slowly at 0, 0, going to infinity. And now we can determine the minimum. We know it's between -1 and 0. So second and calc, -1. Oh, sorry. Are you okay? Okay, we want a minimum, which is 3. And we want from -1 to 0. And give us a minimum. -0.6. And the minimum is -0.034. It's tiny, 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 tiny. So it's at -0.6, comma, -0.03456. Is that clear? Yes? So when we turn, that's what we do. If we go north and we turn, we go south. If we go south and we turn, we go north. Very good. Awesome. Good. So now I would like to go back to a problem like this. We are told this function, we have to create a function now. This is page 392, problem 65. '65, 392 book, of course. So we are told the degree is 4, and multiplicity 2 at x equals 1/2. Multiplicity 1 at x equals 6, multiplicity 1 at x equals -2, and the y-intercept is 0, 18. So here it is. Degree 4, roots of multiplicity 2 at x equals 1/2, and roots of multiplicity 1 at 6 and -2, and the y-intercept is 0, 18. We are asked to find a polynomial degree 4, given these conditions. So a polynomial, this has to be degree 4. How many solutions are we given? How many x-intercepts are we given here? Right? Right. So I'm given x equals 1/2 twice. I'm given x equals 6 once, and I'm given x equals -2 once. So I do not know the leading coefficient of this polynomial, but I know it has to have x minus 1/2 squared, x minus 6, and x plus 2. Would you agree so far? If it doesn't look like this, it will not have 2 solutions 1/2, it will not have 1 solution 6, and you will not have 1 solution -2. Agreed? Okay. Now, I use the multiplicities and the solutions. I have not used this just yet. In a moment we will. So, if I expand this, or not, the information I have is basically helping us determine the leading coefficient. So, what does this mean? Excellent. P of 0 equals 18. Great job. That's all I needed to hear. I don't need anything else. That's all I needed to hear. When x is 0, the polynomial has a function value, or the function value is 18. Awesome. Great job. So then I can plug it in, and that will give us a. So how much is, so I copy a. How much is 0 minus 1/2? -1/2. -1/2 squared is 1/4. How much is 0 minus 6? -6. How much is 0 plus 2? Is 2. And now this is 18. And from here I get a. So first I will simplify. And also simplify again. So I have -3a equals 18. So a equals -6. So now we have the polynomial. We should not leave it as is, though. So the polynomial is -6, x minus 1/2 squared, x minus 6, and x plus 2. This is it. We should expand it. And I'm going to say expand it, please. I'm sure you had good professors and bad professors in your academic career. I did too. And I had one that I will always give us a perfect example of how not to teach. Always. First of all, he would never erase the board. I'm not kidding. And he would do this with his shirt and write in a little circle in the middle. Something. That was one thing that I will never forget. The other thing that I will never forget, he would start writing something. He would not remember how to continue. He would say, from this point it's messy, you do it. So I'm going to say this to you for today. From this point it's messy, you do it. No? Okay, you want me to expand it, we'll expand it. I just don't want to spend the time on it, but if you say expand it, I will. Okay, got it. So I couldn't use my worst example ever today for you. Okay, Good. So remember, a binomial squared has how many terms? X squared minus 2 times the first times the second plus the second term squared. Then I will multiply these two and I get x squared minus 4x minus 12. And now I will distribute this x squared to all three, the negative x, and so on and so forth. So x to the fourth minus 4x cubed minus 12x squared minus x cubed plus 4x plus 12x plus 1/4 x squared minus x and minus 3. I distributed simply x squared to 3 terms and negative x to 3 terms, and negative 6 x to the fourth. These two are together, negative 5x cubed. These are together, so negative 48 plus 1, negative 47 divided by 4x squared. Then this is 16 minus 1 and minus 3. And finally, I distribute negative 6. So it'll be over 2. It'll be positive. 1, 2, 141. Correct my numbers, please. And minus 80x and plus 18. Yes, Mike, go ahead.
On the test, are you going to ask us to expand it? Or are you
Yes.
gonna ask us to-
Yes, you have to expand it. I just was lazy. I didn't want to expand it today. I wanted to make you expand it without my help. But it didn't work out. You can not always win, right? Sometimes you have to lose. So I lost, but I lost to my students, and that's always allowed. Okay, any questions? Yes, yes. And it's guaranteed to have, as you see, 0, 18, the y-intercept, and those 4 given solutions. 2 of 1/2, 1 of 6, and 1 of negative 2. Guaranteed. Any questions? Okay, I think the next section is 5.4. I always like to show you where we are, so you know. Okay, oh yeah, so if you want me to show another rational inequality, the rational inequalities have to wait for another minute. But if you want me to show another polynomial inequality, we can. So now I like to continue with division of polynomials or dividing polynomials. And then the zeros, this is a very important topic for calculus. And then hopefully we start and finish 5.6 today. Rational functions. They restricted to only 2 categories. So they said that the topic of slant asymptotes is not required. I think it is, but I already crossed it out. I'm not going to talk about slant asymptotes. Okay, ready? So dividing polynomials. Polynomials. Now, there are 2 different methods. However, my colleagues decided do not do synthetic division. I like synthetic division very much, but it says where synthetic division is suggested, long division may be used. So they crossed out synthetic division as well. So that's fine. So we're going to look at long division, but still, if we divide a polynomial by one monomial, one term, that's one category of division, one type. And if we divide a polynomial by any other polynomial, not a monomial, that's a different type. And this is what it's called long division. I'm sure you remember it from other classes, math classes. So I just want to illustrate, such a division is not here, but I need to illustrate with one example. For example, let's say we have x to the fourth minus 3x squared minus 1 divided by x cubed. We don't use long division for something like this, or synthetic division. We have to separate it into 3 fractions. So one fraction will be x to the fourth over x cubed, the other one 3x squared over x cubed, and the last one will be 1 over x cubed. Do not get into the idea that you can always do that. You can separate into 3 fractions here only because this quantity is one term, one product. If you have 2 terms, you cannot do that. It's not going to help. You can, but you're not going to be able to simplify. But here I can simplify, and this becomes x. I can simplify, and this becomes negative 3 over x, and here I cannot do anything. And you will say, what have you accomplished? You have accomplished nothing. Well, this is very important for calculus, to be able to separate the function like this and simplify each fraction by itself. This tells a lot about what the function is doing or where it's going, but that's for limits in calculus. So that's a very important type of division. But so now let's look at the long division. Please choose from here anything you want so we can illustrate the long division. You can see, sorry. 27 it is. So let's look at 27. In 27, we have very good pick actually. 27 on page 400. Thank you. 9x cubed minus x plus 2 divided by 3x minus 1. So we are going to ask ourselves a couple of questions first. Here's the first question I ask myself. Are both in descending order?
Yes.
If they are not, I have to rearrange them. Now the second question at the top. Is the top missing any term? You can say, how do I know?
Yeah.
What is its degree?
3.
So I have to have a degree 3, a degree 2, a degree 1, and a degree 0 in there. I have to have normally 4 terms. If the degree is 3, I have to have 4 terms. Degree 3, degree 2, degree 1, and degree, not power, degree 0. So it's missing 1 term. I will have to leave some space where the missing term should have been, right? So 9x cubed minus x plus 2, and I'm dividing by 3x minus 1. So then, here is what I do next. I ask myself, 3x times 9 times what is 9x cubed? 3x multiplied by what is 9x cubed? And the answer is 3x squared. Excellent. I now have to distribute 3x squared to these 2 terms, change the sign, and write below like terms. Why I change the sign? Because I have to subtract. 3x squared times 3x is 9x cubed, but I need to subtract. 3x squared times negative 1 is negative 3x squared. I change to the opposite sign, and of course I cannot write it under this term. I cannot write it under that term either. So then I have 3x squared, and I bring down the next in line. Next step. I'm asking myself 3x times what is 3x squared? And the answer is 3x times what is 3x squared? The answer is positive. At the top, we do not lie. I like to say that to my students. The top is true. X times 3x is 3x squared. But when I distribute it, I have to change the sign because I subtract. And x times negative 1 is negative x. I subtract. Bring down the next in line. I can continue. So the answer will be quotient 3x squared plus x plus remainder over the divisor. Now you can say, I don't trust this. What if it's not true? How do I check? Let's say I want to check this. How do I check? How do I check that 10 divided by 3 is 3 integers and 1/3? 3 times 3 plus 1 is 10. 3x minus 1 times 3x squared plus x plus 2 must equal 3 times 3 plus 1 must equal 10. This times this plus 2 must equal that. If it doesn't, then my answer is wrong. So let's say we want to check. So 3x squared plus x multiplied by 3x minus 1 and plus 2. If the answer is not this, then the answer is wrong. We have to start from scratch. So let's do it. So let's say I distribute from here. 3x times 3x squared, 9x cubed, then plus 3x squared, and then minus 3x squared, and then minus x and plus 2. These two go away, and I get 9x cubed minus x plus 2 as expected. Which means indeed that this is the quotient, this is the remainder, and this is the divisor. Quotient, remainder, divisor. And this is our long division. Now I would like to choose one example, like let's say 22, because I like to explain something. 22 on same page, 400. Any questions about the long division, please? Any questions about long division?
Why couldn't you just set what you had got after doing all the long division, the 3x squared plus
Yes.
x plus the remainder,
Yes?
and then try to set that equal to the 9x cubed minus x plus 2? Why did you turn it again to the check formula that you have, which is those two quantities plus?
Because in order to check that 10/3 is 3 plus 1/3, I have to multiply 3 by 3 and add 1 to get 10.
Well, it just seems like such a random thing to try and do after you did all that work. A long division.
We don't have to check. I just wanted to check and show how to check in case you have any doubts. We don't have to check. Michael, just 1 second. So in order to check that, I have to apply the same procedure. I have to multiply the divisor by the quotient and add the remainder to obtain 9x cubed minus x plus 2. Is that clear?
Yeah.
Yes? We didn't have to check. But I just wanted you to see that if you have any doubts, if you think that maybe you messed up a sign or something is wrong, then you can always go back and check. Here, once we got 9x cubed minus x plus 2, it's obvious that the answer is correct. Caleb, is that okay?
Yeah.
Did that answer your question? Yes, Mike, sorry.
Would it also be able to do like to set x in both equations, like the first before you divide them, and then what you get after they're divided by a number like 10, and then solve both of them to see if you get the same answer?
So you would like to divide?
Like if you set the question like 3x minus 1 divided by 9x cubed minus x.
But it's the other way around, it's 9x cubed minus x plus 2 divided by 3x minus 1.
Okay, you do that, but you substitute x for a number, and then you solve that, and you get an answer, and then you solve the 9x cubed minus x plus 2 with the same number.
So you will just plug in top and bottom a number and you see if you get the same number on the right hand side?
Mhm.
Have you never done it that way? It's possible. Yeah. Other questions? Other questions? Okay, so let's look at 22 on page 400 because I like to ease our way into something very important. So 3x cubed minus 5x squared plus 2x plus 3 divided by x plus 2. I'm assuming you see and you agree that all checks out. They are in descending order. There is no missing term from the top. The degree is 3, degree 3, degree 2, degree 1, degree 0, not power, but degree 0. And we are ready to start 3x cubed minus 5x squared plus 2x plus 3 and x plus 2. Okay, so can anyone give us the first step?
We have to multiply by x plus 2.
So we say x times what is 3x cubed, and this is 3x squared. We go back and distribute. 3x squared times x is 3x cubed, so minus 3x cubed. 3x squared times 2 is 6x squared, minus 6x squared. Perform the operations we see. Bring down the next in line. X times what is negative 11x? Negative 11x. Negative 11x times x is negative 11x squared, so plus 11x squared. And this is negative 22x plus 22x. And then 24x. And then plus 24. And I bring down the next in line. So negative 24x and negative 48. So negative 45.
I think you've just done synthetic. Yeah.
Yes, they crossed it out though. Yes. I'm going to get to that in a minute, what I was going to say about that. So let's write the final answer. So this is 3x cubed minus 5x squared plus 2x plus 3 divided by x plus 2. Can anyone give us the final simplified form and perfect?
3x
Yes.
Minus 11x plus 24. Careful. Minus 45 over x plus 2. Okay. There is something we call the remainder theorem and the factor theorem. Remainder and factor theorem. There are two theorems, but I like to present them together.
You're saying how they're notated? One side is the remainder, and the other side is.
No. So I hope you agree that this setup, this division, is a polynomial divided by something like x minus a number. Would you agree? Only in this situation, the remainder and factor theorem are applicable, or theorems if you want, are applicable only when we have a polynomial divided by x plus or minus a number. What about the previous case? Could I have used the theorem? I haven't even explained the theorems, but I'm just asking. Could I have used the theorem here? Yes, only when I write this and I disregard the 3 for a while till I put it back in. But not with a number in front. So I can divide this by x minus 3 and then further divide by 3. In this particular case, I don't have to do that because the denominator is already clean, plain 1x plus or minus a number. So in these situations, the remainder is P of A. And that's the remainder theorem. And I'm coming back for the factor theorem in a moment. So now, because of this division by x minus a number, which in this case, how much is A in this case? Careful. How much is A here? Perfect, negative 2. So then I would like to check if the remainder is indeed negative 45, doing what? Calculating what? P of, I already asked, how much is A? So what do I have to determine? P of? Exactly. Excellent. If P of negative 2 is not negative 45, one or the other methods has an error somewhere. Ready? So we denote by P of x the 3x cubed minus 5x squared plus 2x plus 3, and we plug in negative 2. 3 times negative 27 minus 5 times 9 minus 6 plus 3. Let's see what we get. See, I said minus 2 and I plug in negative 3. I am not here today. Disregard me. Completely disregard me. Do not trust what I say or do today. I was at the funeral yesterday, and I'm still.
Sorry for,
It's a colleague from here. So negative 24 minus 20 minus 1 is indeed negative 45. Someone who taught for us for 35 years. Okay, so indeed we got negative 45 as expected. The remainder of this division, as you notice, can be determined without finding the quotient. So if there is a remainder as, if we divide by x plus 2 or x minus 5 or x minus 3, whatever, and we are only interested in the remainder, we do not have to use the long division. We can directly plug in negative 2 in p and we obtain the remainder. So now the second part of this theorem is this. Please tell me what happens if I find that p of a is 0. What does that mean? Exactly. When I divide p of x by x minus 2 plus 2, whatever you want, and I plug in negative 2 in our case, and I get 0. There is no remainder. What does that mean? And that's extremely important.
X is equal to
Say it again?
A. X is equal to A.
No?
taking it just another round.
Correct.
Well, 0 times whatever that is gonna be is gonna be.
No?
And
Just need to simplify.
Correct. That's the idea. Which means that x minus a is what for p of x?
it might be
So that means
X.
that x minus a is a for p of x. I need the key word there. And we can never forget this. It's extremely important.
Factor.
Thank you. So every time a remainder, that's why I put these two together, because they belong together. The remainder theorem and the factor theorems, they belong together. So if I'm asked to determine the remainder, or if I want to check whether an expression like linear expression, linear factor, right? X minus 5, x plus 2, and so on and so forth, is a factor of a polynomial. All I have to do is determine the remainder using the remainder theorem. And if the remainder is 0, what do I conclude again about x minus a? It's a factor of p of x. Okay, so now we're ready to look at a couple of examples. If I find it. I did. Okay, here they are. For the following exercises, use the remainder theorem. For the following exercises, use the factor theorem to find all real zeros for the given polynomial function. So we're going to talk about this in a minute, but let's start with use the remainder theorem to find the remainder. So here we're not asked to divide. We're not asked to find the quotient. We're only asked to identify whether there is a remainder or not, if the divisor is a factor of the top or not, in other words. And then in the second set, we will choose a problem and then find all zeros of the given polynomial. Ready? So find all zeros for the given polynomial function and one factor. So we are given one factor. We're asked to determine the other ones. Ready? So please choose. Which one?
9.
9 it is. Okay, very good. So number 9 on page 412. 9. Okay, negative 3x squared plus 6x plus 24. And this is x minus 4. We want to use the remainder theorem to find the remainder. We're not asked to find the quotient. So the numerator is always denoted by p of x. So what do I have to do in order to find the remainder of this division? Say it again. So this is the numerator is p of x. What we have to find in order or calculate in order to determine the remainder.
X minus one.
Anyone?
Solve for P4.
Exactly. We have to find p of 4. So negative 3 times 16 plus 6 times 4 and plus 24. So negative 48 plus 24 plus 24 is 0. What do we conclude?
Wait, why did we
I'm sorry?
why is it X
It's right there.
Where did you
See?
minus?
At the top of the page. So the remainder is always determined by p of a. Is that okay? It's right there, p of a. I have to find p of a. X minus a is here, x minus a, and I have to find p of 4.
Is it a factor? X minus 4?
Yes, because the remainder is 0. We conclude, very good. X minus 4 is a factor of p of x. Any questions? Is this, yes, please.
So like, you're not gonna solve it by long division?
We're not asked to do that. The question was only asking us to find the remainder.
So there was
And by finding the remainder, you made x equals 4. That's what the done.
Okay, so let's go back. Let's go back. When we divide a polynomial by x plus 1 or x minus 3 or x minus 7 or x plus 15, if we only want to determine the remainder, all we have to do is find p of a. And that's what we determine.
So even if
We
had-
determine p of a.
Even if you had, instead of x minus 4 under the denominator, you had x plus 4.
You would have
How would
replaced,
that change a? Would that be negative 4 then?
of course, you have to compare it to x plus minus a. So x minus 4 compared to x minus a tells us that a must be 4. If you compare x plus 5 to x minus a, that tells us that a must be negative 5.
Okay.
So once we plug it in and we get the answer, that's the remainder. If you want to use synthetic division or long division, you will get the same remainder.
Okay, but one,
But you will work much harder because we're not interested in the quotient at this moment. Since the remainder was 0, we also applied the factor theorem. Every time the remainder is 0, it means that x minus 4 in this situation is a factor of p of x. Okay? Any questions? Is this okay?
so if it's 0, it's a factor.
Only if it's 0, of course.
And if it wasn't 0, it wouldn't be a factor.
Right, don't we?
There would be
We
no
understand that. So 9 divided by 3 has remainder 0 because 3 is a factor of 9.
Okay, yeah, I got it.
But 10 divided by 3 has remainder of 1 because 10 is not divisible by 3.
It's not.
Questions? Okay, so let's look at another one with finding the rest of the factors. So they're giving us a polynomial. Anyone would like to choose from 14 to 21? We are given a polynomial. They are degree 3.
16.
And we are giving us a factor, which is x plus 3. Okay, 16, very good. And they're asking us to determine the rest. Okay, 16 on page 412. And we have f of x equals 3x cubed plus x squared minus 20x plus 12. And they say that there is one factor of x plus 3. So what is the degree of this polynomial? 3. How many factors can it have?
3.
Of course. And we are given 1.
Yep.
Good. So we will use long division to determine the quotient. 3x squared plus 3x cubed plus x squared minus 20x and plus 12. Once they are telling us that this is a factor, what should be the remainder when I finish the synthetic?
Zero.
When I finish the long division, what would be the remainder if I am told from the very beginning that x plus 3 is a factor?
0.
Of course. So we know if we get something else, then we know something is wrong. So then this is 3x squared minus 3x cubed, positive, so minus 9x squared, negative 8x squared, bring down the next in line, negative 8x, positive 8x squared, negative 24 plus 24, 4x and plus 12, and here it is, the 3. Negative 4x, 4. Negative 4x and minus 12.
Where did you get the 8x squared from? Oh, I see.
So indeed the remainder was 0 as expected. So for now I know that this polynomial has x plus 3 times what? Can anyone identify times what?
3x squared.
Of course, of course. They're asking us now to determine the other two factors. So we can take that trinomial aside and find the other two factors. So 3x squared minus 8x plus 4. 3 times 4 is 12. I'm using this method. You can use any method you like. So now I factor by grouping. So this is x, 3x minus 2. And I have to get a 3x minus 2, which means negative 2. So 3x minus 2 and x minus 2. So now I have all three factors. I have x plus 3, I have 3x minus 2, and I have x minus 2. Given a polynomial degree 3, one more time, I was also given a factor. I was able to determine the other two factors. But after applying long division to determine the quotient, once I have the quotient, I see degree 2, and I try to factor them. Any questions here? Any questions? Questions for me? I like to look at a word problem before we move on. Any questions? Any questions? Okay. In that case, I'd like you to choose a word problem. And these are on page 413. The circled ones are the recommended ones. You can choose anything you want that is, oh, too close, too close, too close. Okay, so let's look at a few and make a decision. Let's say the length is 1 inch more than the width, which is 1 inch more than the height. The volume is such and such. For the following exercises, find the dimensions of the box described. For the following exercises, find the dimensions of the right circular cylinder described. You choose.
77.
The cylinder? Which one?
77.
77 it is. 77 on page 413. Okay. For the following exercises, find the dimensions of the right circular cylinder. So let me just refresh your memory on how we determine, let's say, the volume of a circular cylinder. This is a circular cylinder, and the volume is area of the base times the height. So the area of the base is pi r squared times the height. Okay. So that will be the volume. What about the surface area? Assuming we don't have to add these two, the area, the pi r squared twice. So what will be the surface area?
Pi r squared times 2.
2 pi r.
2 pi r times the height. The circumference of the base circle or the circle times the height. 2 pi r times the height.
Oh, if it's, yeah, okay.
Yes. Okay, so let's see what they want. We didn't even read the problem, so we really don't know what they want. So it says the height. So let me draw. So this is the height, and this is the radius. The height is 1 less than 1/2 the radius. The height is 1 less than 1/2 the radius. So we have to establish something very important here. You have $100 in your pocket, and I tell you that I have 10 less than what you have. Am I telling you 10 minus 100 or 100 minus 10? 100 minus 10. Okay, so be careful with that. Very good. Excellent. So the height is 1 less than 1/2 the radius. Very good. Awesome. Awesome. Very good. The volume is 72 pi cubic centimeters. Find the dimensions of the right circular cylinder. So we don't have the radius and we don't have the height, but we do have the volume and we have a relationship between the height and the radius. So remember we said a volume is the area of the base, pi r squared, multiplied by the height. The volume is given to us as 72 pi. We have pi r squared, and the height is given to us as 1/2 r minus 1. I only put the information I have.